Hello everyone, my name is Himanshu Shekhar Punde and I am going to explain important functional groups in organic chemistry. All of you are studying in either in 11th or 12th standard, so this video is too much helpful for you. So let's start our video. First of all, we will take a look of our contents. It contains introduction, then alkane, alkenes, alkynes and arenes, halides, cyanide and isocyanide, nitro compound, alcohol and phenol, amines, ethers, aldehyde ketones and carboxylic acid, ester, amide. It contains primary amide, secondary amide and tertiary amide, acid anhydride, acyl chloride and sulfonic acid. Remember my friend, this is just an introductory video for this is an introductory video to the functional groups. Okay, so we will just take introduction of these all functional groups, the structure of these functional groups and few examples. Okay, for details, for few chapters I have already made the videos which are available on this channel, and for few concepts the videos will come out over the period of time. Okay, so let's start our video. So what is a functional group? Organic chemistry is basically contained upon carbon. All the things or most of the things are made by carbon or joint with carbon, and as we all know, the valence of carbon is 4. So playing with that valency, few groups are made, few functional groups are made. So the functional group refers to a specific group of atoms or bonds within a molecule which is responsible for its characteristic chemical reactions and properties. These groups are reactive centers of organic compounds and determine the reactivity and behavior in various chemical reactions. They usually consist of a combination of carbon, hydrogen, oxygen, nitrogen, sulfur and other elements. They are attached to carbon backbone of the molecule and significantly influence the compound's physical also chemical properties. The presence of different functional groups imparts unique chemical characteristics to organic compounds, making it easier for chemists to predict their behavior and interactions. Our very first functional group is alkane. So simply alkane is not any separate functional group. It is just an carbon and 4 hydrogens using single bond fulfilling its valency. So this is called as an methane. Suppose I have taken 2 carbons. Now I will add 3 hydrogens each to fulfill the valencies, and all the 3 hydrogens are joined to the carbon atom by single bond, and also the carbon and carbon atom is joined with a single bond. So this structure is referred as ethane. Similarly, if 3 carbons are there, it is propane. 4 carbons are there, it is butane. 5 carbons, pentane. 6 carbons, hexane. 7 carbons, heptane. 8 carbons, octane. 9 carbons, nonane. 10 carbons, decane. And so on. This is for alkane, ANE. ANE is the suffix. Okay. And ALK. What is ALK? That is alkyl group. In further reactions, you will repeatedly see this word R. R means alkyl group. R refers to an alkyl group. Alkyl group means any carbon attached with hydrogens. I will explain you with the example. So instead of giving every time carbon and hydrogens, R is written. So R can be CH3, R can be C2H5, it can be C3H7 and so on. So we will discuss it later when R comes. Next is alkene or olefin or olefins. In this structure, now it is an interesting part. Now two carbons are joined by double bond, carbon-carbon double bond. So, as we all know, carbon has valency 4. So now what will happen? This carbon already made two bonds. So it will attach only two hydrogens. And similarly here also. This is called as alkene. And next is alkyne. Now the carbon-carbons are joined by triple bond. Now they will attach an R group. R group means, let's suppose anything can be attached. Suppose this is carbon, 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 triple bond. R means, let's suppose I have attached CH3. Now this is R dash is given. Now what is the difference between R and R dash? It is simple. If R is here, that will be CH3. So then R dash will be a different alkyl group, not same. So it can be C2H5. Okay, this is for alkyne. Or two hydrogens can also be attached to alkynes. So alkyne means, alkyne refers to carbon-carbon triple bond. Again, we will take a look. Alkane, in alkane, carbon-carbon have single bonds. In alkene, carbon-carbon have double bonds. And in alkyne, carbon-carbon have triple bond. Now arenes. Arenes means it is an aromatic hydrocarbons or aromatic ring. Let's suppose benzene ring, or now this one is methyl benzene. Methyl group is attached. Remember my friend, I have already explained it in previous videos. Here nothing means carbon, and to fulfill its valency there are three hydrogens. So it will be methyl group attached to benzene. Here nothing means carbon, nothing means carbon. Three hydrogens attached here. And it is already making two bonds, so two hydrogens are attached here. It is nothing but C2H5 means ethyl group, so it is ethyl benzene. So arene means aromatic hydrocarbons, okay, or aromatic ring. What is aromatic ring? It should contain a benzene ring, means a six-membered ring which contain alternate double bond and single bond. Six-membered ring should be there, but it also contain an alternate double bond and single bond. These two factors are very important for an arene. Now halides. Halides are the group 17 elements. Now see the group 17 elements. And all are electronegative elements, and their charge is minus. Let's suppose F minus. F has minus charge, Cl also minus charge, Br also minus charge, I also minus charge. So fluorine, chlorine, bromine and iodine. These are the halides. They are generally or commonly referred as X in organic chemistry. X, halides means X. Okay. So whenever you see X in organic chemistry, that is halide. So now my friend, tell me what will be the name of Rx, or what we can refer to Rx. R means our which group? Alkyl group. X means halide. So Rx means alkyl halide. So R can be written as CH3, X can be written as Cl. So CH3Cl, that will be methyl chloride. Now we will see few examples of this one. Now look here. Now in this case, this total group will refer as R and this group will refer as X. So the name, the common name is tert-butyl chloride. Why tert-butyl? This carbon is tertiary carbon. It is attached with three carbons, three carbon containing three CH3 groups or three methyl groups, and overall four carbons are there. Overall four carbons mean butyl, and it is tertiary butyl. So tert-butyl and Cl means chloride. This is common name, and IUPAC name will be 2-chloro 2-methyl propane. Okay. Now this one is allyl bromide. Br group is attached, so bromide. This is cyclohexyl bromide. Br group is attached. When Cl is attached, chloride. Br is attached, bromide. Iodine is attached, iodide. And F is attached, fluoride. So mostly we see chloride and bromide are attached rather than fluoride and iodide because of their atomic sizes. Okay. Now cyanide or nitrile. It contains carbon and nitrogen triple bond. As we all know, the valence of carbon is 4 and the valence of nitrogen is 3. So C triple bond in, it is also termed as cyanide or it is also termed as nitrile. And R group is attached. R group can be any any carbon containing group. So let's suppose this example propane nitride. In this C triple bond is there and another two carbons are attached, CH2, CH3. But when we name them, when we name that structure, this carbon is also counted. So first, second, third. So it will be propane nitride. This one is 4-ethyl. This one is 4-ethyl hexane nitrile because it has 1, 2, 3, 4, 5, 6 carbons, and on the fourth carbon it has attached with ethyl group. So 4-ethyl, 6 carbon, that was hexane and nitrile group. So 4-ethyl hexane nitride. Next is isocyanide. Rn triple bond C. Now what is the difference between cyanide and isocyanide? Now N is in between the two carbons. N is joined with triple bond carbon here, compulsory, and R group or AR group is attached. R group means carbon containing in an aliphatic chain or alkyl chain, and AR means aromatic ring. So it is always surrounded by carbon. So now N is in between the two carbons. That's why it is also called as iso group. Okay. On the both side carbon is there. So iso means same element is there on the both side. That's why it is called as iso. It is called isocyanide. Now why this plus and minus? Why this plus and minus signs are given? Any guesses? Because carbon has valency of 4, but now here carbon is only making 3 bonds. Okay. So it's one extra electron that will be minus. Okay. Or one lone pair of electrons. And similarly nitrogen has valency of 3, but it is making an extra bond, so it has plus charge. Okay. So the few examples of isocyanide are methyl isocyanide, CH3NC. It is short form NC. CH3CH2 ethyl isocyanide, CH3CH2CH2 propyl isocyanide, and C6H5NC phenyl isocyanide, phenyl or aromatic ring. Okay. These are the common names, and IUPAC name as methyl carbylamine, ethyl carbylamine, propyl carbylamine, and phenyl carbylamine. So it is simply termed as carbylamine group. Okay. Next is nitro compound group. It is shortly termed as NO2 because it contains one nitrogen, because it contains one nitrogen and two oxygens. So in short, it is written as NO2, and it is attached to R group. Okay, so RNO2. So the examples are CH3NO2 means nitromethane. Now nitro group is written as a prefix, not a suffix. Okay, when we are writing IUPAC name. So nitromethane. Now what is the name of this structure? It is an benzene ring. On the first and second position nitro groups are attached. There are two nitro groups, that way it will be dinitro, and they are attached at first and second position. So it will be 1,2 dash dinitrobenzene, or its common name will be O dinitrobenzene. O means ortho group. They are attached to their ortho positions. Okay, I already explained what is ortho metapara in this channel. Next one is alcohol. Alcohol is very easy. ROH. R can be, so it can have primary alcohol, secondary alcohol, tertiary alcohol. Simple is methanol. Methanol means carbon, 3 hydrogens and OH. So it will be methanol. What is primary alcohol? Primary alcohol means simply the carbon to which OH is attached, that is further attached only with one carbon. What I said, the carbon to which OH group is attached, that is further attached to only one carbon group. So it will be primary alcohol. Now what will be secondary? The carbon to which OH group is attached, that is further attached to two carbon groups. That is secondary alcohol. And what is tertiary alcohol? The carbon to which OH group is attached, that is further attached to three carbon containing groups. So that will be tertiary alcohol. Now phenol, that is AROH. OH group is attached to an aromatic ring. These are few examples of phenol: hydroquinone, resorcinol, and metacresol. Amine contains RNH2. Secondary amine contains now one hydrogen is getting removed and two R groups are attached to that nitrogen. And tertiary amine contains third hydrogen getting removed out, and all three R groups, because valency of nitrogen is only 3. Okay, so 3 R groups can be attached when it has neutral charge. Ether contains R or R dash, means oxygen is in between the two alkyl groups. So one alkyl group, it can be two same alkyl groups, means CH3O, CH3, or it can two different alkyl groups. So it contains simple ethers and mixed ethers. So that are the types already explained on this channel. Um, it will be, so the name of this structure will be CH3, CH2O, CH2, CH3. Now it contains two ethyl groups. So its common name will be diethyl ether. Two ethyl groups, that's why diethyl. And it is an ether, so it is diethyl ether. Or its IUPAC name will be eth. On the left side, ethane is there. So eth in between oxygen, so that's why O. And on the right side, ethane. So ethoxyethane. This one is methyl ethyl ether or methoxyethane or ethoxymethane or ethyl methyl ether. Then next one is 2-methoxy 2-methyl propane, and this one is diphenyl ether or phenyl ether or phenoxybenzene. Next one is aldehyde ketone and carboxylic acid. When R group is attached to C double bond OH, it is aldehyde. When on the both side R and R dash group or both R groups are there, it is ketone. And when R group and OH group is attached to an carbonyl carbon, it is called as carboxylic acid. These are the few examples of aldehyde: formaldehyde, propionaldehyde, acetaldehyde, and butyraldehyde. Ketone, these are the few examples: propanol, acetophenone, benzophenone, 2-pentanone, 3-methyl, 2-butanone, 3-hexanone, etc. Carboxylic acid: formic acid, propionic acid, acetic acid, and butyric acid. Ester. Now our next one is ester. Now what is different between the ester? Now ester contains R, C double bond O, one more oxygen is there, one more oxygen, one more oxygen is there, and R dash group. So it is an ester. Amide. Amide means here is carbon, here can be carbon, here can be carbon double bond O, C double bond O, and nitrogen. Two hydrogens are attached. This is primary amide. Now why primary amide again? Because the nitrogen is directly attached to only one carbon. Now next one is secondary amide. Why? Because it can be connected to two carbons simultaneously. Here also carbon, it will be an CH3 group or anything, and here also carbon. So it will be secondary amide. In tertiary amide, all three carbons are attached, but one of the carbons should be a part of carbonyl group. So few these are the types of amides. Next one is acid anhydride. Anhydride contains two carbonyl group, that is C double bond O, C double bond O and C double bond O, attached with an single bond oxygen. And on the both sides, it can be R or R dash, or it can be AR, AR, anything will be there. So it will be anhydride group. Acyl chloride or acyl halide. If it is Br, it will be acyl bromide, or X is there, acyl halide, as we have discussed already, halide. So RC double bond Cl, it is acyl chloride. Simply this group is called as acyl group. This group is called as acyl group. Sulfonic acid contains R, S double bond O, S double bond O, OH, or it is written as H, S, it is written as H, S, O thrice. Okay, and it can be attached to an R group. H, S, O thrice, and it is attached to an R group. Now sulfur is attached, not hydrogen is attached directly. Okay, HSO thrice. Why? Because it contains three oxygens. Okay, or it can be termed as SO3H also. So thank you so much. This was a very short video containing only the we have just introduced ourselves to the functional groups. I have not explained thoroughly the examples, not explained thoroughly the IUPAC and common names and not explain their functions. It was just an introductory video to all, to most of the, not all, most of the important functional groups which are there in organic chemistry. Once you know these functional groups, you can easily solve the IUPAC names and common names. Okay, so I have, for reference, I have used HSC class 11 chemistry textbook and NCERT grade 11 chemistry textbook. So thank you so much. Keep watching and keep supporting my channel. Thank you so much.